correspondence students. In the last class, we discussed about the moving of a car or moving of a vehicle in a circular road. That is a plain circular road, right? So if we consider this one as a plain road, so if any vehicle or any car which is moving on this plain road, plain circular road, right? So this circular road having a radius r, right? So the maximum speed of the car in the plain circular road, we derive that one as v, that is equals to under square root of mu s or g, right? So where r is the radius of the circular road, that is the plain circular road. And also we discussed, so this is the maximum speed in which the vehicle moving in a plain road. So namge in value bandide, so this is the maximum speed, so we call this one as v max, right? So if the vehicle is moving more than this speed, for example, if the speed of the vehicle is some 50 meter per second, right? So this is the maximum speed in which the vehicle will move in a plain circular road, right? So in case if the vehicle crosses the speed which is greater than 50 meter per second, right? So that means if the vehicle is moving with a speed of 80 meter per second, then the necessary force to keep this object or keep this vehicle in a circular track or a circular path, so that centripetal force will not balanced by the frictional force that is caused by the tires of the vehicle onto the road, right? So here we have the force. So now previous class ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೇನು ಅಂದ್ರೆ ಯಾವುದಾದ್ರೂ ಆಬ್ಜೆಕ್ಟ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ so there is a force which required to that object to move in the circular path, so that force is the frictional force, right? So due to the frictional force the object due to the centripetal force the object will move in a circular path. So this necessary centripetal force is provided by the frictional force, so that's why we taken Fc is equals to Fs, right? So we know Fc is equals to mv square divided by r. If the speed of the vehicle, that is v, is more, that means the centripetal force is more. So as the centripetal force increases, so this force will not provided by the frictional force. So here frictional force remains constant, right? So for that this will not be balanced by the frictional force. The centripetal force is greater than that of the frictional force, so hence the vehicle will slip away from the road, right? So now the vehicle has to move with the maximum speed in a circular path, so hence we did the edge of one side of the road is made a little height, right? So if we consider this as inner edge and this one as the outer edge, right? So that means banked road, car which is moving in a banked road. So banked road means one edge or outer edge of the road is made little above than the inner edge. That means, so previous example discuss ಮಾಡಬೇಕಾದ್ರೆ as this is the circular road, right? So this one is the plain road, so idu plain ಇದೆ, that means the road is leveling. So bank road ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ outer edge of the road we made with a little above than the inner edge, so that by some angle theta. So that means one side of the road ಏನಿದೆ height ಇದೆ, ಇನ್ನೊಂದು side of the road ಏನಿದೆ normal flat ಇದೆ. So inner edge ಇರುತ್ತೆ same. Again from here where r is the radius, right? So road ee tara height alli ide andre again the car will also some tilt, right? So car will be like this. Right? So car ಏನಾಗುತ್ತೆ ಆ ಶೇಪ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ನಮಗೆ. ಸೊ ಪ್ಲೇನ್ ರೋಡ್ ಅಲ್ಲಿ ಈ ತರ ಇರುತ್ತೆ, ಇನ್ ಬ್ಯಾಂಕ್ಡ್ ರೋಡ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ರೋಡ್ ಹೈಟ್ ಆಗಿರೋದ್ರಿಂದ ಕಾರ್ ಕೂಡ it will tilt towards the inside, right? So now here we are going to find the maximum speed of the vehicle which is moving in a banked road, right? So now discussing on the forces which acts on the car. Now here also the car moving with a constant speed or uniform speed, right? Forces acting on a car in a banked road. Right. So in the first one, weight of the car. So that is W. So weight of the car is always in the downward direction. That is W. That is equals to mg. Right. So next, second one, normal force. That is contact force by the road on the car. So that we take normal. That is perpendicular to the contact surface of the car. So road ge perpendicular draw madidre, so that we written as the normal force, right? So and third one, friction. That is friction is the frictional force, right? So friction between car tire and friction force between the car tire and right. So that is friction force, right, in this manner. That is here, right. So here we are going to find the speed of the car. So ಇದನ್ನ ನಾವು ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ next we will discuss about free body diagrams, right? So considering this as path, so adune ನಾವು ಇಲ್ಲಿ in terms of force ಅಲ್ಲಿ represent ಮಾಡ್ತಾ ಇರೋದು, right? So here is the angle theta, weight is acting downward, that is W is equals to mg, and friction is acting here, that is Fs, and the one more force, that is normal, right? So in these two we are representing the free body diagrams of the car, right? So now resolving the normal force along the horizontal and vertical component. So this is the normal force. We are resolving this normal force along the vertical and along the horizontal, right? So this normal force making an angle theta with the vertical, right? So this force become n cos theta, right? So the same normal force if I resolve along the horizontal, so we get that one as n sin theta, right? So now here we having the friction. So friction also we are resolving along the horizontal and vertical component. So ಇಲ್ಲಿ angle theta ಇದೆ ಅಂದ್ರೆ, so alternate angles here also we getting the theta. So now the friction we are resolving along the horizontal and along the vertical. So theta along horizontal ಇರೋದ್ರಿಂದ, so Fs cos theta. That is the frictional force which is acts on along the horizontal, and the same Fs sin theta, vertical force, right? So these are the forces which are acting on the car when it is in bank road. So car bank road ali, so these types of the forces which are acting on that car, right? So now balancing the forces. So balancing the forces means upward forces is equals to downward forces and inward force is equals to the outward force. So aduna ಏನಂತ ಕರಿತೀವಿ ನಾವು, balanced forces or balancing the forces. So now balancing the forces here is the first force is n cos theta, which is acting in the upward direction, right? So that is n cos theta, right? So that is equals to the forces which are acting downwards. So here forces which are acting downwards, one is weight of the car and another one is Fs sin theta. So these two are the forces which are acting downwards, right? So n cos theta, that is equals to mg plus Fs sin theta, right? So from this we can write this one as mg, that is equals to n cos theta minus Fs sin theta, right? So calling this one as equation 1. So equation ಅಲ್ಲಿ the one was balancing the forces. So upward force, that is equals to the downward force. So upward force we having only one force. So idu force is the normal which is inclined. So iduna ನಾವು consider ಮಾಡ್ತಿಲ್ಲ, only the force which is vertical, right? So normal ಅಲ್ಲಿ ಏನು force act ಆಗ್ತಿದೆ, that is the component of the normal force, that is n cos theta, that is equals to mg plus sin theta. ಎರಡು force downward act ಆಗ್ತಿದ್ರೆ one force upward, right? So next, so all these three forces, that is the frictional force Fs cos theta and n sin theta. So these forces are acting inward, that is towards the center of the circle, right? So e force ಯಾವ ಕಡೆಗೆ act ಆಗ್ತಿದೆ, towards the center of the circular path. That means this force is balanced by the which force, that is the centripetal force Fc, right? So now we can write that one n sin theta plus Fs cos theta, that is equals to, these forces are balanced by the center. We have the value mv square divided by r. So that is equals to mv square divided by r. That is second equation, right? So now divide equation 2 by equation 1. So we are dividing the equation 2 by equation 1. That means LHS term ಅಲ್ಲಿ ಇರೋದನ್ನ LHS term ಜೊತೆ ಡಿವೈಡ್ ಮಾಡಬೇಕು, RHS ಅಲ್ಲಿ ಇರೋದನ್ನ RHS ಅಲ್ಲಿ ಜೊತೆ ಡಿವೈಡ್ ಮಾಡಬೇಕು. That means we taken this one as mv square divided by r whole divided by mg, right? That is equals to n sin theta plus Fs cos theta divided by n cos theta minus Fs sin theta, right? So dividing equation 2 by equation 1. So here we have m, here we have m, get cancelled. So we can write this one as v square divided by rg, that is equals to, right? So v square divided by rg, that is equals to, so from the definition we have frictional force Fs, that is equals to mu s into n, right? So this is from the definition. Static frictional force, that is equals to coefficient of static friction into the normal force. So wherever we have Fs, we need to substitute that one, right? So that is n sin theta plus mu s n cos theta divided by, so n cos theta minus, so here we getting 1 minus mu s sin theta by cos theta, right? So n cos theta get cancels, right? So from the trigonometry, sin theta by cos theta, we can write that one as tan theta, right? So LHS keeping as is v square divided by rg, that is equals to tan theta plus mu s divided by, so here 1 minus mu s tan theta. So in the trigonometry, sin theta by cos theta is tan theta. So we need the speed v. So shifting rg to the RHS, so v square is equals to rg into tan theta plus mu s by 1 minus mu s tan theta. So we need only the v. So v is equals to under square root rg into, we can write this one as mu s plus tan theta divided by 1 minus mu s tan theta. So this gives the maximum speed of the car on a banked road, right? So in plain road, we getting the maximum speed V max is equals to under square root of mu s r into g. So this is the maximum speed in a plain road, and here in banked road. So ಇಲ್ಲಿ ನಾವು 80 meter per second speed ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ರು ಕೂಡ in a banked road we can go in the same speed without lowering the speed of the vehicle, right? So ಯಾವುದೇ ತರದ್ದು ಡ್ಯಾಮೇಜ್ ಅಥವಾ ಆಕ್ಸಿಡೆಂಟ್ ಆಗಲ್ಲ ಕೂಡ ನಾವು ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಹೋಗಬಹುದು. So that we given by the relation E is equals to R into G. So this is under square root R into G mu s plus tan theta into 1 minus mu s tan theta. So this is very important for 5 marks derivation in board exam, right? So derive the relation for the maximum speed of a moving vehicle in a banked road means you need to derive the relation V is equals to under square root of Rg into mu s plus tan theta divided by 1 minus mu s tan theta, right? So tumba very important derivation. So exam alli ee diagram baridale hodru kuda, so this diagram is very important, right? So here theta we call banking angle. So now ಎಷ್ಟು angle ಅಲ್ಲಿ road ನ bank ಮಾಡ್ತೀವೋ, so ಅಂತ angle ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, banking angle, right? So ಅಲ್ಲಿ ನಾವು car diagram ಏನು necessity ಇಲ್ಲ, so just one box represent ಮಾಡಿದ್ರೆ that indicates what car. So here also the three forces are acting: weight of the car, normal force, and friction between the car tires and the road, right? So special cases, we have the relation V is equals to Rg plus mu s tan theta divided by 1 minus mu s tan theta if the friction between the road and to that of the car is 0. That means the coefficient of static friction mu s is equals to 0. That means there is no friction between the road and the car. Then the car will move with the speed V is equals to under square root of, so wherever mu s we need to substitute 0. So 0 plus tan theta divided by 1 minus 0 into tan theta is 0. So tan theta by 1 is tan theta. That is V is equals to under root of Rg tan theta. So this is one special case when the coefficient of static friction is 0. That means there is no friction acts between the car and to that of the road. So that we have the coefficient of static friction. So compare relations here. So V max, here also V max. So plain road alli namage mu s Rg ಇದೆ. So ಇಲ್ಲಿ V is equals to root of Rg tan theta, right? So this is one special case when the object which is moving with a lesser friction or zero friction. That means there is no friction between the vehicle and to that of the road, right? So these are the two important relations from the diagram. So important derivation is 5 marks ಗೆ board exam ಅಲ್ಲಿ ತುಂಬಾ ಸಲ ಕೇಳಿದ್ದಾರೆ. So simplification ಮಾಡಬೇಕಾದ್ರೆ practice ತುಂಬಾ important, right? So ಇದನ್ನ ಈ ಕಡೆ ಬರ್ಕೊಂಡು ಇದನ್ನ ಈ ಕಡೆ ಬರ್ಕೊಂಡು ಎಲ್ಲ ಸೇಮ್. ಸೊ ನಮಗೆ ರಿಲೇಷನ್ ಬರ್ಕೊಡ್ಬೇಕಾಗಿರೋದಕ್ಕೋಸ್ಕರ we are dividing the equations 1 and 2, right? So by this we completed the chapter that is laws of motion. So ಇಲ್ಲಿಗೆ ಈ chapter complete ಆಗಿದೆ. So remaining problems on all these concepts. So conservation of linear momentum, ಮತ್ತೆ F is equals to ma. So ಈ ಮೆಥಡ್ಸ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕು. So next and the most important methods on problem solving, so that is free body diagrams. So ಇಲ್ಲಿ ನಾವು ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇರೋದು ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್. ಸೊ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಅಲ್ಲಿ ನಾವು ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಸೊ ಈಸಿ ಮೆಥಡ್ ಅಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಅಂದ್ರೆ ನೋಡಿದ ತಕ್ಷಣ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಸೊ ದಟ್ಸ್ ವೈ because contact means either the objects, two objects may be in contact or more than two objects are in contact. So in that situation we are going to refer the free body diagram, right? So in that first one, so this is the surface. So on this surface, if any object is placed which having the mass m, so idu basic. So first one, ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಇದೆ. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ನ ಯಾವುದೋ ಒಂದು ಸರ್ಫೇಸ್ ಮೇಲೆ ಪ್ಲೇಸ್ ಮಾಡಿದ್ವಿ. ಆಲ್ ದೀಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇಸ್ ಬೇಸ್ಡ್ ಆನ್ ದ ಫೋರ್ಸ್. ಸೊ ಹಿಯರ್ ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ವಾಟ್ ಆರ್ ದ ಫೋರ್ಸಸ್ ವಿಚ್ ಆರ್ ಆಕ್ಟಿಂಗ್ ಆನ್ ದಿಸ್ ಆಬ್ಜೆಕ್ಟ್, ರೈಟ್? ಸೊ ಈ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ಸಪರೇಟ್ ಆಗಿ ನಾವು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಳ್ಳೋದನ್ನ ಏನಂತ ಕರಿತೀವಿ? ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್. ಸೊ ಆಸ್ ಇಟ್ ಇಸ್ ನ ನಾವು represent ಮಾಡ್ಕೊಂಡ್ರೆ, so this we are going to find the forces on this object having the mass m, right? So ಇಲ್ಲಿ ನಮಗೆ two forces acting. One is it acts the contact force on the surface, so that is the weight of the object onto the surface and it is always downward, so that is mg, right? So mg is the weight which is acting by the object onto the surface. So same again from the Newton's third law. So e object surface mele some force act ಮಾಡ್ತಿದೆ ಅಂದ್ರೆ from the Newton's third law this surface is also acting some force on that object, right? So that we call as the normal force which is perpendicular to the surface which is in contact. So aduna ನಾವು ಏನು represent ಮಾಡ್ಕೊಂತಿದೀವಿ here, right? So from this we can relate n is equals to mg. So individual agi ನಾವು ತಗೊಂಡು ಅದರಲ್ಲಿ ಎಷ್ಟು forces act, because here there are no external forces which are acting on this object, only the two forces, one is normal force and another one is the weight, right? So from this we can relate n is equals to mg. So ಇದನ್ನ ಈ ತರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಳ್ಳೋದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್, right? Next second example, when the same object which is hanging to the roof. So ಯಾವುದೋ ಒಂದು ರೂಫ್ ಇದೆ, ಈ ರೂಫ್ ಗೆ some object of mass which is hanging, right? So ಇಲ್ಲಿ ಕೂಡ ನಾವು ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ this is for the mass m. So ಇಲ್ಲಿ ಕೂಡ ನಮಗೆ two forces act ಆಗ್ತಾ ಇದೆ. So this we call as a string. So it has a massless and inextensible string. So ಇದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ? massless and inextensible string ಅಂತ ಕರಿತೀವಿ. Here the string is in contact with the object having some mass, right? So here weight is acting downwards, that is mg. So the same which is balanced by the string, so that is we call as the force. So that force we call as the tension T. So tension ಯಾವಾಗಲೂ ಯಾವ್ದ್ರಲ್ಲಿ ಇರುತ್ತೆ? string ಅಲ್ಲಿ ಇರುತ್ತೆ. So from this we can relate T is equals to mg. So ಇಲ್ಲಿ ಕೂಡ ಯಾವುದೇ ತರದ್ದು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇಲ್ಲ, right? So this we take on the same. So some object which is hanged by the two strings, right? So ಈ ತರ ಇಂಡಿಕೇಟ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಇದನ್ನ ನಾವೇನಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ? So this one is the rough surface or fixed surface ಅಂತ ಕರಿತೀವಿ. ಸ್ಟ್ರೈಟ್ ಲೈನ್ಸ್ ನ ಸ್ಟ್ರೈಕ್ಸ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ fixed surface ಅಂತ ಕರಿತೀವಿ, right? So here we having the object of mass m which is hanged between the two fixed surfaces with the two strings. So that means here also we having the force, that is one is weight which is acting always downwards. So and other two are the forces, one is acting on the here, another force that is T, right? So if we resolve this T1 along the vertical and horizontal and also T2 along vertical and horizontal. So ಇಲ್ಲಿ your reference you can take. So particular problems alone they will mention T1 makes an angle theta with the vertical or with the horizontal. So here I am taken angle theta with the horizontal. So here also either these two thetas may be same or different. So theta 1 theta 2 ಇರಬಹುದು ಅಥವಾ ಇಲ್ಲಿ ಬೇರೆ ವ್ಯಾಲ್ಯೂ ಇತ್ತು ಅಂದ್ರೆ ಇಲ್ಲೂ ಬೇರೆ ವ್ಯಾಲ್ಯೂ ಇರಬಹುದು ಅಥವಾ ಎರಡು ಸೇಮ್ ವ್ಯಾಲ್ಯೂ ಇರಬಹುದು, right? So now if we resolve tensions, so tension is nothing but force. If we resolve those two forces along horizontal and vertical, so here we getting T1 cos theta, so here we getting T1 sin theta. So here also T2 sin theta, so here it is T2 cos theta, right? So the forces which are acting on this mass, so upward force is equals to the downward force if the object is at equilibrium. So object equilibrium ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಎರಡು ಫೋರ್ಸಸ್ ಏನಾಗಬೇಕು, ನಮಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಆಗಬೇಕು. That's why T1 sin theta plus T2 sin theta, that is equals to mg. So this is one relation. So again two forces which are pulling outside. So T1 ಆ ಕಡೆ pull ಮಾಡ್ತಾ ಇದೆ, T2 ಈ ಕಡೆ pull ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ that means T1 cos theta, that is equals to T2 cos theta. So ಇದು equations ಬರ್ಕೊಳ್ಳೋದಕ್ಕೆ method, right? So particular problem ಅಲ್ಲಿ ಹೋದ್ರೆ ನಮಗೆ what we are going to find, either we can find the tension in the string or on which angle these two are hinged with the object. So ನಾವು ಇದರಲ್ಲಿ mass ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು, angle ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು ಅಥವಾ tension in a string ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು, right? So this is the basic, that means skeleton form ಅಂತ ಕರೀತೀವಿ. ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್ಸ್ ನ ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಫೋರ್ಸಸ್ ಎಷ್ಟು ಆಕ್ಟ್ ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಳ್ಳೋದನ್ನೇ ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ ಥರ್ಡ್ ಕೇಸ್, that means ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿಕೊಂಡು ಪ್ರಾಬ್ಲಮ್ ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬಹುದು. So in this case, surface, on this surface object m1 which is placed on the surface, and on the object m1 one more object is. So the total force in the downward direction is sum of the two weights which is acting downwards, so that has to balance, means the total force is n. So the total normal force acting on the two objects is represented by n, so that we written as equals to n1 plus n2, right? So that is equals to n1, we have m1g plus m2g, right? So that is m1 plus m2 into g, so that is acting downwards. So this force is acting here. So ಎರಡು force downward act ಆಗ್ತಿದೆ, that is m1 plus m2 into g. So this is balanced by the force, that is n, because the object is at rest. So rest ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಯಾವುದೇ ತರದ್ದು ಫ್ರಿಕ್ಷನ್ ನಾವು ಇನ್ನೂ ಕನ್ಸಿಡರ್ ಮಾಡಿಲ್ಲ. ಸೊ ಫ್ರಿಕ್ಷನ್ ಬಂದಾಗ ಇನ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲಿ ಫ್ರಿಕ್ಷನ್ ಬಂದ್ರೆ ನಾವು ಫ್ರಿಕ್ಷನ್ ಕೂಡ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಫ್ರಿಕ್ಷನ್ ಯಾವಾಗ ಬರುತ್ತೆ, ಫೋರ್ಸ್ ಮಾಡಿದಾಗ ಫ್ರಿಕ್ಷನ್ ಬರುತ್ತೆ, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ವಿ ರೆಪ್ರೆಸೆಂಟಿಂಗ್ ದ ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್ಸ್. ಸೊ ಇದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಾವು ಟೋಟಲ್ ಫೋರ್ಸ್ ಎಷ್ಟು ಆಕ್ಟ್ ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ವಿ ಕಾಂಟ್ ಸೇ ದಟ್ ಒನ್. ಸೊ ದಟ್ಸ್ ವೈ ವಿ ಟೇಕನ್ ಇಂಡಿವಿಜುವಲಿ each masses and the number of forces acting we are representing, right? So ಇವನ್ನೆಲ್ಲ ಏನಂತ ಕರೀತೀವಿ ನಾವು, ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್ಸ್, or we simply FBD. So FBD means free body diagrams, right? So ಇದು ನಿಮಗೆ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಇಲ್ಲ, ಬಟ್ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಈ ತರದ ಪ್ರಾಬ್ಲಮ್ಸ್ ತುಂಬಾ ಕೇಳ್ತಾರೆ. ಇದೇ ತರದ್ದು ಅಂದ್ರೆ these are the basics, so we need to apply these laws in those problems. So mass m1 m2 m3. So diagram represent ಮಾಡ್ತಿದೆ ಅಂದ್ರೆ size vary ಆಗ್ತಿದೆ, m3 is greater than m2 which is greater than m1, and all these three are connected with the string or thread, and this is pulled with a force F. So one force ಅಲ್ಲಿ pull ಮಾಡ್ತಾ ಇದ್ದಾರೆ. So we need to find the total force or tension. ಏನು ಬೇಕಾದ್ರೂ ನಮಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಕ್ಕೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಬಹುದು, right? So here if we draw the free body diagrams for the individual, right? So first if we write for the free body diagrams for M1. So force which is acting on M1, we taken that one as F. So force in act ಆಗ್ತಿದೆ M ಮೇಲೆ act ಆಗ್ತಿದೆ. That is the first object M1. So ಇಲ್ಲಿ weight ಮತ್ತೆ normal force ಎರಡು cancel ಆಗುತ್ತೆ. So that's why we are not considering here, right? So here it is connected with the string. So string connect ಆಗಿದೆ ಅದರಲ್ಲಿ ಏನಿರುತ್ತೆ ನಮಗೆ? There is a tension T1. So these are the two forces which are acting on the object M1, right? So now for M2. So M2 is connected with the string, right? So the same string which is connected between M1 and M2. So ಇಲ್ಲಿ M1 ಅಲ್ಲಿ tension T1 ಇತ್ತು ಅಂದ್ರೆ M2 ಅಲ್ಲಿ ಕೂಡ ಇದೇ thread ಅಲ್ಲಿ tension ಎಷ್ಟಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ, that is T1, right? So another string is connected between M3 and M2. So ಇಲ್ಲಿ T1 ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ನಮಗೆ T1 ಇರಲ್ಲ because these two are connected with the same string, so that's why the forces are same. So here these two are connected with the different string, so that's why we taken that one as T2. So here T1 and T2 are the two forces which are acting on the object M2, right? So and the last is, so here we need to mention in which direction the object is moving, right? So acceleration of the object towards the right side. So force apply ಆಗ್ತಿದೆ ಅಂದ್ರೆ objects ಏನಾಗಬೇಕು, ಮೂವ್ ಆಗಬೇಕು, right? So on the last is M3. So here M3, the string is connected to M2, so the tension is T2, right? So adu bitre bere yavadru force idana, so there is no force, so hence the object is moving right side. So ee kadeಯಿಂದ full ಮಾಡಿದ್ರೆ ಈ ಮೂರು objects it will move in the positive x axis, right? So these we call as free body diagrams. So now blind agi ಎಷ್ಟು force ಆಗ್ತಿದೆ, ಎಷ್ಟು acceleration ಅಲ್ಲಿ object move ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ನಾವು ಹೇಳೋದಕ್ಕಾಗೋದಿಲ್ಲ, right? So individually ನಾವು find out ಮಾಡ್ಕೊಂಡ್ರೆ we can find the acceleration, right? So here, so ನಿಮಗೆ problem solve ಮಾಡೋವರೆಗೂ understand ಆಗೋದಿಲ್ಲ, but these are the forms, right? So next 5, right? So one more, this is the rigid surface or fixed surface. Fixed surface is connected to the pulley, and on this pulley we connected two masses of M1 and M2, right? So here if you apply for the free body diagram, so idu ಕೆಳಗಡೆ ಇದೆ ಅಂದ್ರೆ mass of M2 is more than M1, idu common sense ಅಲ್ಲಿ. So M2 ಯಾವ್ದು ಜಾಸ್ತಿ ಇರುತ್ತೋ ಕೆಳಗಡೆ ಹೋಗಿರುತ್ತೆ, right? So if we apply for the free body diagrams for M1, so these M1 and M2 are connected with the same string, right? So M1 ಅಲ್ಲಿ weight act ಆಗ್ತಿದೆ, that one is M1G, right? So that is balanced by the another force, that is the tension which is acts on the string. So the object is moving in the upward direction, so acceleration is in the upward direction, right? So next, if we write for the free body diagrams for M2, here also weight is acting in the downward direction, that is M2G, and it is connected with the string, the same string which is connected between M1 and M2, right? So the tension which is acting on the string is T, right? So here the object is moving in the downward direction, so acceleration is in the downward direction. So ಈ object ಎಷ್ಟು acceleration ಅಲ್ಲಿ ಕೆಳಗಡೆ ಹೋಗುತ್ತೋ, so same acceleration ಅಲ್ಲಿ object ಏನಾಗುತ್ತೆ, ಮೇಲ್ಗಡೆ ಮೂವ್ ಆಗುತ್ತೆ, right? So this we represented by the free body diagrams. So ಎರಡು diagram use ಮಾಡ್ಕೊಂಡು ನಾವು either we can find the acceleration or mass of the object or tension in the string. Next. So next, in an inclined plane, so any object which is moving in an inclined plane with an angle theta, right? So inclined is andre it moves with an acceleration in this direction. So slide ಆಗ್ತಾ ಇದೆ. So here also we need to represent in free body diagram. So free body diagram again taking this object in the same direction. So here the forces which are acting is, one is mg, right? So the another one is normal, right? So this normal we can resolve into two components. One is n cos theta, where theta is the angle which is found with the vertical and n sin theta, right? Or the other one we can resolve the same. So ನಮಗೆ ಯಾವ್ದು ಬೇಕೋ ಅದನ್ನ ನಾವು ರಿಸಾಲ್ವ್ ಮಾಡ್ಕೋಬಹುದು. Same example, weight acting is downward mg and n, right? So now we can resolve this mg along the vertical and along horizontal, right? So this we take as mg cos theta, and here it is mg sin theta. So here we get triangle theta. So these are the forces which are acting on an object. So now problem ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ ಅಂದ ತಕ್ಷಣ ಇದು ಯಾವುದನ್ನು ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋದಿಲ್ಲ. Just they are mentioning the object which is sliding on an inclined plane when the angle theta ಕೊಟ್ಟಿರ್ತಾರೆ ಅಥವಾ moving with acceleration ಕೊಟ್ಟಿರ್ತಾರೆ. We need to find all these forces. So ಇದು ಯಾವುದನ್ನು ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಆಗಿರೋದಿಲ್ಲ. These are the methods to solve or simplify to find the values of acceleration or force or inclined planes. So depend on the situation. So ಯಾವ situation ಅಲ್ಲಿ ಏನು ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟಿರ್ತಾರೋ ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋದಕ್ಕೆ we are following the rules. So that is the free body diagram. So ಎಲ್ಲದರಲ್ಲೂ ನಾವು as the chapter we are studying in the contact force. So here the object is contact with the inclined plane. So here the three objects which are connected with the string, or if they mention here they are connected with the spring, again we need to draw the same free body diagrams. Without free body diagrams we can't solve the problems, right? So idu nimge tellali irbeku. So free body diagrams ಹಾಕೊಂಡ್ರೆ ನಿಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಗುತ್ತೆ, ಪ್ರಾಬ್ಲಮ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಬರುತ್ತೆ. ಬ್ಲೈಂಡ್ ಆಗಿ f ma ಹಾಕಿದ್ರೆ ನಮಗೆ acceleration ಬರೋದಿಲ್ಲ, right? So because there are number of forces which are acting on this object, right? So one more. So ಇದನ್ನೆಲ್ಲದನ್ನು ನೀವು ಡೈಲಿ ಲೈಫ್ ಅಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿರ್ತೀರಾ, ಬಟ್ these we are studying in physics, right? So m1 m2. So ಇಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿರ್ತಾರೆ if m2 is greater than m1 then the object will starts to slide or move downward direction. So again here we are going to draw the free body diagram. First we need to find the free body diagrams for m1. So here the force acting is only the tension T. So remaining m1g and normal, those two are get cancels, right? So acceleration, direction of the acceleration is in this direction, right? So this is moving. So we are not considering here the friction, force of friction and now considered madila, right? So in case now force of friction considered madala, again one more will come, that is the friction, right? So neglecting the friction. So next m2. So m2 weight is acting in the downward direction, that is m2g, and it is connected with the spring. The same string is connected between m1 and m2. So ಇಲ್ಲಿ ನಾವು ಒಂದೇ ಸ್ಟ್ರಿಂಗ್ ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಏನು ಟೆನ್ಷನ್ ಇರೋದು ಈ ಸ್ಟ್ರಿಂಗ್ ಮೇಲೆ, the same tension will be on the m2 object. So that's why we taken T. So ಇಲ್ಲಿ different strings ಇರೋದ್ರಿಂದ T1 T2 ಅಂತಾನು ನಾವು ತಗೊಂಡಿದ್ದೀವಿ, right? So this is the free body diagram and the object is moving downward direction. So this we call that as the net force which is acting downward direction. For example, if someone is pulling this object with the force F, so that means the object is moving in this direction. So the second case under consider ಮಾಡ್ಕೊಂಡ್ರೆ, so ಒಂದರಲ್ಲಿ ಎರಡನ್ನು ಬರೀತೀನಿ, don't confuse both, right? So second case is the red ಅಲ್ಲಿ ಬರೀತೀನಿ, some force is acting or someone is pulling this object, that means the object is moving leftward. So ಈ object left ಗೆ move ಆಗ್ತಿದೆ, ಈ object ಏನಾಗುತ್ತೆ, it moves upward. So free body diagrams na ಬರುತ್ತೆ m1. So one force which is acting towards the F and another one which is the tension T. So observe ಮಾಡಿ, ಇಲ್ಲಿ only one force, that is tension, but in the second case one is force and another one is tension T, and the object is moving in this direction, that is the negative x-axis. So towards left object ಏನಾಗ್ತಿದೆ, move ಆಗ್ತಿದೆ. So this is the free body diagram when force is applied, right? So next for the second case m2. So here one force, that is tension the another one is F to G. So here in this case, the object is moving upwards. So first case ಅಲ್ಲಿ object downward move ಆಗ್ತಿದೆ, but second case ಅಲ್ಲಿ object upward move ಆಗ್ತಿದೆ. So these are based on the given situation. So ನಮಗೆ ಯಾವ situation ಮೆನ್ಷನ್ ಮಾಡಿರ್ತಾರೋ ಅದ್ರ ಮೇಲ್ಗಡೆ ನಾವು ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್ಸ್ ನ ಡ್ರಾ ಮಾಡಬಹುದು, ರೈಟ್? So problems now simplify ಮಾಡಬೇಕಾದ್ರೆ we will discuss on these topics. So these are the general forms. So idu basic, you need to know these ones, right? So ತುಂಬಾ important for competitive exams ಈ ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳೋದು, right? So in the next class we will discuss with the problems which they are asked in board exam, right? Thank you.